Was the host what?
He's back.
Muted. Okay, is this better now?
Yeah, that's a
Yes.
lot better.
I tell you, I hate technology. If I to mention that, how much I hate technology, technology just sucks. Sucky technology, stupid technology. Okay, well, anyway, now let me do the share screen thing. And here we go. And now I'm going to have to get it on my iPad. Okay. 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 And now here's our happy little circuit, okay? And I got to tell you, you know, they've given us power and they've given us voltage, okay? And oh, okay, the screen share is like totally laggy. So let me stop the screen share and start it again. Here's a second. It's not doing it. So let's try this again. No, it's not doing it. So I'm going to stop it and try it again. Screen share. Okay. All right, now it's working. This is just, so anyway, so Zong, are you still with me? Who's asking about this?
Yeah, I'm still here.
Zong, okay, good. Okay, so you see the circuit, right? And of course it's now frozen. Oh, okay, now it's working.
Yeah.
So looking at the circuit, there's two ways to do this. I can find the resistance of each individual resistor, and I can find the resistance of each individual resistor by doing power equals V squared over R, because I know the power of each resistor and I know the voltage that each resistor is getting. Each resistor is getting 120 volts. Okay with that? So I could get the resistance of each individual resistor and then using that power. But you know what? Why do it for each individual resistor? Because aren't they asking just for the current out of the battery? You know, I mean, let me look. What the heck are they asking for? They're asking find the equivalent resistance of the three devices and obtain the total circuit. So they don't really care about any of the devices as individuals, but they only care about the resistance of the three devices together. So instead of using a power of one of the individuals, why not just use the complete power, 1650 plus 1090 plus 1250, okay? And that's gonna equal 120 volts squared over the total resistance of the circuit. You see that? I don't have to get the resistance of the three individuals, even though I could, and I'd get the same answer, but I might as well just get the total resistance of the entire circuit. And so I end up with 120 squared divided by 1650 plus 1090 plus 1250. Okay, so I get 3.6. So I get an equivalent resistance of 3.6 ohms. All righty. And I've written that down, but my thing is totally lagging. So I get equivalent resistance of 3.6 ohms. Yay, that's part A. And now to do part B, all I have to do is V equals IR. They want to know the total current out of the battery. Hey, I got 120 volt power supply, and I've got 3.6 ohms that's attached across that power supply, and then just solve for the current. So is that okay with you, Zong?
Yeah.
Okay, now, did you try to do it by finding the resistance of each individual resistor?
Yeah, I did it that way and I got the same answer.
Oh, good for you. Great. So yeah, and again, one of the beauties about chapter 20 about DC circuits is there's more than one way to skin a cat, you know? Yeah. Any other questions or issues on any of these problems?
Can you go over number 70?
Number 70, which?
Oh, number 70, homework 38.
Number 70. Okay, I heard the 70 part, but I didn't hear. Okay, hold on just one second. I have an iPad that I was using to access the book, but that iPad, the battery in that iPad died. And so I had to charge that iPad up. So now I've charged it up, so I can go ahead and access the book on that iPad now. Okay, just one second. It wants my email. I didn't happen to save it on my password, so I have to type the whole stupid thing in. Just one second, I'm signing into Vital Source. And okay, wow, finally. And then this is problem number 70. Okay. Sorry about these delays. This is like really frustrating, you know? It's like, oh yeah, we're in the 21st century. I'm using technology. And like everything takes forever. Oh, this is just ridiculous. Okay, here's what I'm gonna do. I need to stop the sharing and start it again in the hopes that I don't have infinite lag. Okay, here we go. Okay. All right, well, it looks like there's no lag there. And now I'm looking at Vital Bookshelf and I'm getting to problem number 70, but it's taking a long time. Okay, that's still working, yay. Wow, okay, that took long enough. So how long did that take me to finally get there? 5 minutes. Okay, so here's number 70. And who's asking about number 70 again?
Oh, me. Yeah.
Okay, great, thank you. Thanks for your patience. So determine the power supplied to each of the resistors in the drawing. All righty, so step one, of course, is to make an actual schematic. Okay, they tell me that this is 120 volts DC, and they tell me that this is 576 ohms. This is 576 ohms. And this is, they're all the same. Oh my God. Okay, well, if I want to get the power supplied to each of the resistors, though really the strategy, especially for you high schoolers, is step one, you want to get the equivalent resistance that the battery sees. And then step 2, you want to get the current that's coming out of the battery. And then step 3, you can go ahead and answer their question, answer whatever crazy question they ask you. But step 1 is always to get the equivalent resistance and get the current out of the battery. So in this case, I've got a 576 ohm resistor that's in series with two 576s that are in parallel. So 576, in a parallel with 576. Okay, so that's my resistance right now, a 576 in series with a couple of 576s in parallel. Well, I hope you remember that two identical resistors in parallel is equal to 1/2 of their total resistance. So I'm going to have 576 plus 576 over 2, because the two 576s in parallel equals a single, 200 and what is that, 88? 288. So I've got 576 plus 288. 288, which is going to be 864. So I've got a total resistance, equivalent resistance of 864. Now I can find the current out of the battery, and it would appear, no, I guess it froze. Now I assume it's going to be laggy for the rest of the time. So my current out of the battery is going to be V over R, so it's going to be 120 volts divided by 864 ohms. And so I got 120 divided by 864, which is about 0.14 amps. So now, okay, here comes, yeah, I'm lagging. So, oh, my internet connection is unstable. Okay.
Hey, Mr. Shane, I have a question.
Yeah.
It's Kyler. What do you do if you did 576 over 2? What if they're not the same number?
Oh, then you would have to use the formula that the equivalent resistance of two resistors in parallel is 1 over the first resistor plus 1 over the second resistor, quantity to the -1 power. That's the general formula for two resistors in parallel.
Oh.
And if it was 3 or more, then it would be 1 over R1 plus 1 over R2. Yeah, is that good? Yeah, but rule of thumb, if you've got identical resistors in parallel, why deal with that ridiculous formula? Just either, just take the resistance and divide by the number of resistors. So anyway, so now that I got my current out of the battery, I can answer anything else they want. They want to know the power supplied to each. Well, I know that this resistor is getting 0.14 amps. And I know that he's a 576 ohm resistor, so his power is going to be I squared R. So all I have to do is just take that current, square it, and multiply by 576. In addition, because I've got a current divider here, when you have resistors in parallel, that's a current divider, and your 0.14 amps is going to be divided between these two pathways. Well, because both pathways have identical resistances, your current is going to be divided in half. So it's going to be 0.07 amps and 0.07 amps. And now again, you can use I squared R, or you can just use the fact that, if you're cutting the current in half, you're going to cut the power to 1/4 of its previous amount. And so since this 0.14 squared times 576, since this guy is 11.3 watts, this guy is using 11.3 watts, and I know that I'm having half of the current for each of these guys. That means each one of these guys is going to be 11.3 divided by 4. Because I'm cutting the current in half, which means I cut the power to 1/4 its previous value. So is that okay with you, Dominic?
It is. Thank you.
Yeah, you're welcome. So, hey, anything else? I think if someone asked another question, I wouldn't waste 5 minutes getting everything ready. Any questions?
I have a question.
Yes.
Are you doing questions on 37 too?
I'll answer any and all questions, because some of you, maybe didn't even do any of the assignments until yesterday or the day before. So I'm ready to just answer any and all questions. I don't know what your personal schedules have been like.
Okay, can you do either 1, 2, or 3 on 37? Doesn't matter which one.
Oh, is that the Xerox?
Yeah.
Okay, here. My 5 more electronics problems, Xerox. So looking at number one, since I already did it in a previous meeting, I'm just going to kind of talk my way through it. Okay, so on number one, just like the previous problem I did, your first step is to, oh wait, my camera turned off. Okay, let's see. Okay, great. Your first step is to get the equivalent resistance of the circuit. And so looking at the circuit, I've got a 20 and a 30 in parallel with each other, and then they're in series with a 3. So the equivalent resistance of the circuit is the 20 and the 30 in parallel, then you add 3. Well, the 20 and the 30 in parallel make 12. 1 over 20 plus 1 over 30 quantity to the -1 power. And then you add 3 to it and you get 15. And so the current out of the battery ends up being 0.4 amps. Once I know the current out of the battery, I can just kind of do the Sudoku thing and work my way around the circuit using V equals IR. So I've got 0.4 amps going through this 3 ohm resistor. So the voltage drop across the 3 ohm resistor is 1.2 volts, meaning since it's a 6 volt battery, that means I'm losing 1.2 volts here. So the voltage at this point is 4.8. So these two resistors both have 4.8 volts across them. So I can find their currents, 0.24 amps and 0.16 amps. And yeah, I think that pretty much answers all their questions. Yeah.
Mr. Shana?
Yes. Hey, Alexa.
Hi. So for number one, I got all the answers right, but I got them times 10, and I'm not sure why. Like I got 4 for the first current, and then I got like 48 and 12 and 1.6 instead of like.
What voltage? Well, first of all, did you get the equivalent resistance as being 15 ohms?
I got 1.5. I think that's what I.
Okay, yeah, then something, yeah, because actually you've got 20 ohms and 30 ohms and 3 ohms, so it should have been 15. So my suspicion is like you may have smashed a bug right between the 1 and the 5, and then from then on or I don't know, but yeah.
Yeah,
Should be
okay.
15 ohms, not 1.5.
Okay, thank you.
You're welcome. Any other questions or issues on this Xerox? Does anyone want to see? I didn't happen to do number 3. I did number 2. I could talk about 2 or work my way through number 3 or 4 or 5. I don't know. Any questions or issues on any of these?
Could you do number, what was it? Could you do number 4 or 5?
Yeah, sure. Let's take a look at them. I already kind of did number 4, so I'm going to talk my way through it. But I want to remind you again, on these simple circuits, step 1 is to get the equivalent resistance of the circuit, and step 2 is to get the current out of the battery. So looking at number 4, this 30 and this 30 are in series, because whatever current enters and exits this 30 must enter and exit that 30. However, this 20 and this 30 are not in parallel. Although they're drawn parallel to each other, they're not actually in parallel. And the reason they're not in parallel is because the right hand of the 30 is not connected to the left hand of the 20. There's this dude in the way, right? This 30 ohm here is in the way. So these two are not in parallel with each other. So I added the 30 with the 30 to make 60, and then I've got the 60 in parallel with the 20. So I figured that out, and then once I found out what that equivalent resistance was, I added 50 to it. And I got 65 ohms as the equivalent resistance of the circuit, which means since it's a 13 volt battery, the current by V equals IR, the current ends up being 0.2 amps. Once I got 0.2 amps, now I can just work my way around. I got 0.2 amps going through a 50 ohm resistor. That's a 10 volt drop, meaning it's 3 volts there. It's still 0 volts there. So I've got a 3 volt drop across the 20 ohm, which means it'd be 0.15 amps through that 20 ohm. And yeah, and of course it would be 0.05 amps through the 60 ohm. So Alexa, is that good for number 4, or is there any, did I go too fast, or is there anything I should elaborate on?
So the 30 ohm like resistor that's in between like the 20 ohm and the other 30 ohm, you have to like split that up, so it's like, so you solve to find one current, you have to split them up because there's.
You mean this 30 and that 30?
Yes.
Well, these two 30s are in series, so you can actually consider this as just one big 60.
60. Oh, okay.
Yeah. Yeah, you'll never
Okay.
be splitting them up per se. It's just actually a 60.
Okay.
So yeah, so I've got a 3-volt drop across the 20 ohm, and I have a 3-volt drop across the 60 ohm. And so 3 divided by 20 is 0.15. 3 divided by 60 is 0.05. And I want to say again, you know, this here ends up being 0.15 amps because 3 divided by 20 is 0.15. This ends up being 0.05 amps because 3 divided by 60 is 0.05. And as you would expect, these two currents add up to the original 0.2 out of the battery, because that 0.2 amps is going to hit this node and split into two smaller currents. And those two currents better add up to the original 0.2.
Okay, that makes sense.
Okay. Thank you, Alexa. Thank you for asking. Any other questions or issues on this wonderful Xerox?
Could you do number 71 on the homework from last night?
Yes, it would be my pleasure. Number 71. You know, they asked about number 71 in the 10 o'clock session, and one huge fake out on number 71 is that even though they label the resistors as R1, R2, R3, and R4 and R5, did you notice that they're actually identical resistors? Adam, did you get that those are identical resistors? Oh wait, you're not muted. Let me unmute you. I can't unmute you. Why can't I unmute?
No,
you?
I didn't notice.
Okay, yeah, because then what happens is, since they're all actually identical resistors, all you have to do is get the equivalent resistance of the circuit. They tell you that your circuit delivers 58 powers. Your battery delivers 58 powers, 58 watts of power to the entire circuit, and they tell you that the voltage of the battery is 45 volts. And so you're going to use power equals V squared over R to get the equivalent resistance of the circuit. And then once you get the equivalent resistance of the circuit, then you can add up all those identical resistors to get an expression for that. In fact, let me just actually go through it. I've got 58 equals 45 squared over the equivalent resistance. So I get an equivalent resistance of, let me get my calculator here, 45 squared divided by 58. So I got 34.9 ohms. And now that 34.9 ohms has to be equal on number 71. I've got R2, R3, and R4, and R5. I've got them in parallel with each other. So I've got one of the R's in parallel with the sum of two R's, because they're in series, that's in parallel with one of the R's. And then once you get that, you're going to add one last R to it, because that guy's in series. The R1, the first R, is in series with that rest of that thing. Well, this is going to be 1 over R plus 1 over 2R plus 1 over R to the negative 1 power plus R, or this is 2, 3, 4, 5. So I've got 5 over 2R to the negative 1 power plus R. And so this ends up being 2R over 5 plus R, or 7R over 5. And that's going to equal 34.9, which I suspect they wanted it to be 35. But anyway, and then you go ahead and multiply both sides by 5/7 and you got your answer. And that ends up being approximately 25 ohms. Yeah. So is that okay with you, Adam?
Yeah, thank you.
Yeah. And this is a case where actually utilizing the formula, without using shortcuts, works out just great. Any other questions or issues on any of the problems?
Can you do 121?
Number 121. Hey, Jada. You're
Hello.
back again. Jada, weren't you there at 10 o'clock as well?
Yes.
Good for you. Oh my God, you are so committed. Number 121, and you're an awesome analyst. Okay, let me get to 121. I'm doing it on my iPad, which for some reason my iPad is like not responding. Here, let me just get it on. I have it on my computer as well. 121. just a second. So a wire has a resistance of 21 ohms. It is melted down, and from the same volume of metal, a new wire is made that's 3 times longer than the original wire. What is the resistance of the new wire? Okay, great. So I've got a wire whose resistance is 21 ohms, and then they make it 3 times longer. But they don't change the volume at all. Okay. So first of all, you're okay that they essentially took a wire that like looks like this, okay? And then they melted it down and made it 3 times longer. Well, if they're gonna make it 3 times longer, they're gonna have to make it thinner, right? Because it's the same amount, it's the same volume of material. So if it's 3 times longer, it's gonna be thinner. How much thinner? Well, it turns out that the volume of a cylinder is the area, the cross-sectional area of the cap, which we call pi r squared, but I can just call it area, times the length, if this is the length of the wire. That is what we call pi r squared h, pi r squared h. It's just the area of the base times the height. Well, now I've got a situation where it's the same volume, but I just made it 3 times longer. So I hope you see that if I made this wire 3 times longer, then I have to have the area be only 1/3 the area. Before I go on, does this make sense, Jada?
Yes, it does.
Okay, good, because that's one of the keys of the problem. So once you've determined that you've not only made the wire 3 times longer, but you made the wire 1/3 the cross-sectional area, then when you use your resistivity formula, resistance equals resistivity times L over A, and you know that this is going to be equal to 21 ohms for the original wire. But now you've got a new wire whose length is 3 times bigger and whose area is 1/3 as much, which means if I factor the numbers out, 3 over 1/3 is 9. So I've got 9 times rho L over A. And then you know that rho L over A is equal to 21 ohms, because that's what it says right up there. And so that's why it ends up being, you increase the resistance by a factor of 9. Because you triple the length and cut the area in half, and resistance is proportional to length. Resistance is inversely proportional to the cross-sectional area. So if you triple the length and cut the cross-sectional area to 1/3 its previous value, it makes sense that you're going to multiply the resistance by 9. So is that okay, Gina?
Yes, thank you.
Yay, you're welcome. Thank you. Anything else? Any other questions or issues you're interested in? What's that? If not, then I'm going to ask you a couple of questions about voltage dividers and current dividers, just really quick. Okay, then here, let me just, if no one has a question, I'm going to.
I have a quick question.
Yes?
What was, how do you solve power again? That's it.
How do you solve power?
Yeah, what's like the equation?
There's 3 equations for power. You've got power equals IV. Power equals current times voltage. Okay. Is my audio going bad again?
It's good enough.
Oh, good enough. Okay. So power is a current. Oh wait, I lost my picture. Okay. So power is current on volume, but you can substitute IR for V, and when you substitute IR for V, you get I squared R. Or in this original equation, you can substitute V over R for I. And if you substitute V over R for I, you get V squared over R. And so there's 3 equations for power, and the one you use depends on what they give you.
All right, thank you.
You're welcome.
Wait, so that V is for voltage, right? And
That's correct.
and so, oh, okay, that makes sense. Okay.
Yeah. Okay, well then, here, a quick question about voltage dividers. So suppose I have a voltage V. I've got a voltage V, and I've got two resistors, R1 and R2. Well, the key to a voltage divider is it's got to be resistors that are in series. And one of the beauties of resistors in series is they all get the same current. So I've got these two resistors in series and they're getting the same current, then I know that the ratio of the voltages will be the same as the ratio of the resistances. That is, if these two resistors are equal, then they'll each have the same voltage drop across each other because they're already getting the same current. But if one resistor happened to be twice as big as the other resistor, let's say that R1 was 20 and R2 is 10, then R1 would get twice the voltage drop because it's got twice the resistance and they have the same current. And so you end up getting this, here's V1 and V2. You end up getting this formula that V1 is going to be R1 over R1 plus R2 times V, and V2 is going to be R2 times R divided by R1 plus R2 times V. You see? But hopefully, when you're a engineer, you would just quickly go, well, R1 is 2/3 of the total resistance, so R1 is going to get 2/3 of the voltage. So if this voltage happened to be 12 volts, then this guy's going to be 8 volts and this guy's going to be 4 volts. 4-volt drop and 8-volt drop, because he's got 2/3 of the resistance, he's going to get 2/3 of the voltage. You see? So hey, you guys ready to do one on your own?
Yes.
Thank you for saying yes.
Yeah.
So let's say that I had a 24-volt power supply here, and I had, this was, let's say this is 6 ohms, this is 2 ohms, and this is 1 ohm, or I don't know, let's make it 3 ohms. Oh shoot, I'm messing this up. Well, let's just make it 6 ohms, 4 ohms, and 2 ohms. Let's just do that. Okay, so I got 6 ohms, 4 ohms, and 2 ohms. Okay, well, can you figure out what the voltage drop across each one of these resistors is pretty quickly?
Yes.
Yeah, go for it. And it's going to be just, whatever percentage of the total resistance you've got, or whatever fraction of the total resistance you got, that's how much of the voltage you're going to get. If people are in love with formulas, then to get V1, it'd be R1 over R1 plus R2 plus R3 times V. That is whatever his fraction of the total resistance is, that's the fraction of the voltage he's going to get, because they all get the same current. Okay, hopefully everyone is doing this.
Is it 12?
Yeah, heck yeah. Yeah, the voltage drop across the
Okay.
6 ohm is going to be 12. He's got half the total resistance. He's going to get half the voltage. Yeah. So how about the 4 ohm? How many volts is he going to get?
8.
Yeah. And this guy's going to get 4.
4.
And you didn't even have to figure out what the current actually is. You just know that the ratio, the fractions that they get is 6 out of 12, 4 out of 12, and 2 out of 12. So that's a voltage divider, and that's the beauty of a voltage divider, is it's something you can do just really quickly in your head without having to do a bunch of math. And the same sort of thing happens with a current divider. Here. Let's say I've got some voltage supply and it's delivering some current, and I've got two resistors, R1 and R2, and they're in parallel. And whenever you have parallel resistances, you got to think in terms of a voltage divider. I'm sorry, you got to think in terms of a current divider, because that current I is going to be split into two smaller currents, I1 and I2. And of course, I hope it's, what do you call, I hope it's obvious to you guys that if R1 and R2 are identical resistors, then I1 and I2 have to be the same current. That is, if your current is approaching this node and neither path has any less resistance than the other path, then you would be equally likely to choose either path because they have the same resistance. So the current's going to be cut in half. But what if R1 is bigger than R2? What if R1 is 20 ohms and R2 is only 10 ohms? Then just the question I want to ask you guys is, who's going to get the lion's share of the current, the 20 ohm or the 10 ohm?
I know.
Yeah, the 10 ohm, because there's less resistance to the flow of current. And you know that old saying, you know, seeking out the path of least resistance. Well, this is where it comes from. My current is going to seek out the path of least resistance. R2 is going to get the lion's share of the current. And in fact, because R2 has half the resistance of R1, R2 is going to get twice the current of R1. And so you end up with an equation that looks like this. I1 equals R2 over R1 plus R2 times I. That is, you know, the current through I1, unlike the voltage dividers, where if you want the voltage drop across to R1, you're going to have R1 be in the numerator. Here, it's the other resistor that gets to be in the numerator. You know, so I1, in this case, I1 ends up being 10 over 10 plus 20 times I, or 1/3, oops, 1/3 I, and he only gets 1/3 of the current because his current his resistance is twice as big as R2, whereas the current through I2 is going to be R1 over R1 plus R2 times I, or 20 over 10 plus 20 times I, or 2/3 of the current. You see what I mean? So that's a current divider. It goes the opposite as a voltage divider. Whoever's got the biggest resistance is going to get the least amount of current. So, hey, you guys ready to do a problem on your own? Here, I'm just going to do a
Yes.
simple. It is just a really simple problem. Okay, and so let's say I told you that this was 2 amps, and I told you that this was 30 ohms, and this is 10 ohms. Could you pretty quickly get how that current, that 2 amps, how's that 2 amps going to get split up between the 30 ohm and the 10 ohm? Andrew, did you get a haircut? Oh my God, good for you. I mean, I haven't been, you know, I haven't gone to Supercuts. I can't get a haircut because we're on shelter in place. So my hair just gets worse and worse. It's a disaster. Good for you. Did your parents like cut your hair?
Once a year though.
Yeah, but I was due for one.
Yeah, my mom did it for me.
Good for you, man. I wish my wife could cut hair.
You should have seen it like 2 weeks ago. It was like a straight up buzz, Mr. Shana. Okay, so anyway, so have you guys gotten the currents yet?
Yeah.
Yeah, I mean, this guy, the 10 ohms, going to have to get the lion's share. In fact, man.
Oh, is that a 30? Oh, shoot.
So the 10
Yeah.
ohm is going to have to get 3 times the 30 ohm, so he's going to get 1.5 amps, and this guy's going to get 0.5 amps. And, oh, whoops, I lost my screen share. Okay, is that going to do it? Do I have to cancel it? And yeah, it looks like I lost my screen share for good. But anyway, oh, here, I'll just redo it. Man, this is just madness. Okay, so anyway, but if you're not good at just seeing it, like immediately getting 1.5 and 0.5, you can always just say, hey, it's going to be the 2 amps multiplied by 10 ohms over 30 plus 10 ohms, and that's going to be I1. That's going to be the 0.5 amps that you're getting there, and then 2 amps times 30 over 30 plus 10. That's going to be I2, which is 1.5 times that, amps. Okay, well, anyway, that's it. Current dividers and voltage dividers in a nutshell. Just remember, with a voltage divider, the bigger resistance gets the bigger voltage drop. But with a current divider, the bigger resistance gets the smaller amount of current.
Can you do like current dividers with more than 2 resistors?
Yeah, yes, I'm going to do one. And mathematically, it's like really, really complex. If I just gave it to you like R1, R2, R3. So for you little high school students, this is the type of problem you would get with a current divider going 3 ways. So they'll actually give you the voltage. So I've got a 24-volt source, and then I've got, let's say this is 12 ohms, this is 6 ohms, and let's say this is 3 ohms. Well, first of all, who's going to get the lion's share of the current, the 12, the 6, or the 3?
3.
Yeah, the 3. But at this point, what you would actually have to use is what the voltage drop across each resistor is. What's the voltage drop across each resistor? Jacob, what is the voltage drop?
Oh, 12. Wait. Yeah.
You were the one asking about this.
12.
No, what's the voltage drop across that 12 ohm resistor? I'll give you a hint. It's connected in parallel across the 24-volt battery supply.
Oh, 24.
Yeah,
Right.
exactly. 24. So, and in fact, that's going to be true for everybody, right? Every single one of these resistors has 24 volts across it. So at this point, you would just do V equals IR. You would go, okay, well, the current here is 2 amps. The current here is 4 amps. And the current here is 8 amps. So at this point, you would discover, oh, then I've got 14 amps coming from the battery. And that's what you would do. You wouldn't use any trickery, with current dividers, because frankly, 3 or more is just too complex mathematically. But you can always double check to go, hey, if he's got half the resistance, he better have twice the current, and if he's got wait, what have I done? Yeah, he's got half the resistance, so he should have twice the current. Yeah, exactly. Or he's got 1/4 the resistance, so he should have 4 times the current. So, you can use your knowledge of current dividers to double check your answer. But for 3 or more resistors, devising a formula for a current divider is just too difficult.
Okay.
Yeah. I tried to do it. My first year teaching this, I tried to teach kids a general formula for current divider for multiple resistors, and that ended up not going well. So I stopped. Hey, anything else on any of this wonderful stuff? Any problems you want to look at? Anything else?
How would it change the the problem if the current was going to the left instead of to the right?
It actually wouldn't change at all. It'd be the same thing. So the only way the current could go to the left, like if it was going like this, the only way that could happen is if you turned your battery around, where you made that the negative terminal and you made this the positive terminal. And then what you would get is the 14 amps would be coming out of the bottom of the battery instead of the top. But everything else would just be the same. It's still a 24-volt drop. It's just now this would be positive and that would be negative.
Oh, okay, so nothing would change.
Yeah, nothing would change, just the directions of the currents. Hey, anything else?
Yeah, could you explain how to get a voltage drop? I'm kind of confused on that.
Voltage drop? Okay, and who's that? Who's asked this?
Tyler.
Okay. Let me see here. Second, voltage drop. How would I get, like on this particular problem, how did I know the voltage drop was 24 volts?
I just mean in general.
Oh, in general? Well, the only formula we have available to us for that is V equals IR. So if you know the resistance and you know the current through the resistor, that's how you get the voltage drop. And that's, I don't know, that's pretty much it,
Doesn't that tell you the amperage or what is it? Current, not voltage. I'm kind of
Yeah.
confused. So doesn't that solve for current, and then how do you go from there to voltage drop?
Oh, well, I mean, you need to know two of these three things in order to get the third. So you know, you can't get voltage without knowing current and resistance. Is there a problem you're thinking about, a particular problem you're alluding to, Tyler?
Well, all the ones you did before, I didn't really know how you did it, so I don't.
Okay. So let me look at one of the ones I did before. Huh. Well, so you're thinking like on that on the Xerox, those types of problems?
Yeah, sure, we'll use that.
Okay, then let me look at a more straightforward problem like number 5. Okay, so Kyler, look at number 5. Okay, so I'm asking for the oh shoot, the current. No, I'm not asking. Well, I'm going to get the voltage drop from A to B. Okay, that's my goal on number 5. Oops, wait a second. I lost my. Okay, let me see. Did I lose it for good? Do I have to redo the screen share? Yeah, it looks like I'm gonna have to redo the screen share. Just a second. Oop. Um, okay, so Kyler, let's say I want the voltage drop from A to B. Alrighty. Well, B is attached to the negative terminal of the battery, so we designate B as 0 volts. Every coulomb of charge that is located there has 0 joules of energy. And oh wait, well A is also 0 volt. No. There's a resistor there. So we want to get the voltage at point A. You know, how much voltage does a guy have at A? Well, in order to answer the question, what's the voltage at A, we really need to know what the current through the 10 ohm resistor is, so I can use V equals IR and figure out what the voltage drop across that 10 ohm resistor is. So to get the voltage at A, I need to know the current through the 10 ohm. How am I going to get the current through the 10 ohm? Well, the way we always do it, I'm going to have to get the equivalent resistance, and then I'm going to have to get the current out of the battery. You see? So quite often it's a multi-step process to get your voltage drop, but still to get a voltage drop, I need current and resistance. I got the resistance, I just need to know the current. Well, I'm gonna get the equivalent resistance. You see that I've got a 100 ohm that's in parallel with 50 ohm. Okay, so I've got 100 ohms in parallel with 50 ohms, and that's gonna be added to 10 ohms. And so the equivalent resistance, a 100 in parallel with a 50 ends up being 33. And then 33 plus 10 makes 43. So I get 43 ohms. And so the current out of the battery is going to be 43 ohms divided by 12. Whoops. It's going to be 12 volts divided by 43 ohms. Again, V equals IR. And that's going to get me 12 divided by 43, which is 0.28 approximately. 0.28 amps. So Kyler, are you okay that I'm going to get the voltage drop across this 10 ohm resistor, but in order to do it, I have to essentially completely describe the circuit, you know? So now that I know that I've got 0.28 amps coming out of the battery, one thing you know is just like water in a hose, whatever water enters a hose has to exit the hose. And whatever current exits the battery has to enter the battery. And so since I've got 0.28 amps exiting the battery, I've got 0.28 amps entering the battery. And now I finally get to do Ohm's law. I've got 0.28 amps going through a 10 ohm resistor. That's 2.8 volts. And there's my answer, 2.8 volts. Oh no, Kyler, does that answer your question?
So the current doesn't change throughout the entire circuit.
Well, no, because this 0.28 amps is getting split 2 ways. So the current changes here because the 0.28 amps hits this node and part of the current goes through the 100 and part of it goes through the 50. And in
Oh.
fact, this is a current divider. So I know the 50 is going to get the lion's share of the current. In fact, since the 50 has half the resistance of the 100, the 50 should get twice as much current as the 100. So the 50 is going to get 2/3 of the current, and the 100 is going to get 1/3 of the current. You see?
And then it like recollects at that point, or
Yes, that's exactly it. That's the way you should think about it.
okay. All right, thank you.
Mhm. You're welcome. Thank you for asking. Anything else? Well, the sun has come out now. My paper is brighter.
So
Yes?
is it like, is it always the less resistance the more current, or is it just for if there's like a divider?
It's a good question. Yes, generally, it has to be a divider. That is, there's a known current going into a node, and then, you know, your current is going into a node, and it has several choices of which path to take, you know, upon exiting the node. And at that point, whichever has the least amount of resistance will get the greatest fraction of that current. But you can't just generally say less resistance means more current, because that depends on your battery. I mean, if you've got a 120 volt battery versus a 2 volt battery, then, you know, your 120 volt battery may end up providing more current regardless, because it's such a big voltage. But definitely in that specific case where you've got a current that has several paths to choose, you know, the bulk of the current will go in the path with the least amount of resistance. So anything else? A lot of people. This is so fun. Kitty. Okay, well then, hey, if we're done here, I'm gonna go back, and so here I am again, and you know, I think I'll probably take a shower after this. I don't know if you noticed, but I haven't washed my hair, so my hair looks terrible.
Should
So
do a
anyway,
wave,
hey
Mr.
kids,
Shana.
any other questions or issues? Yeah, Jacob, any questions?
Can we do a wave? Like
Okay, go ahead, start. Wait, I gotta do my thing down.
So when
Well, I did my job, Win. So are you guys in the same order as me, where it's Jacob, me, and Win, etc.?
No, it changed every time, depending on who's talking.
Oh, okay. For me, it's all constant. So if it was like
Galaxy.
me, Win, Andrew, and Adam, you know, then we could literally do the wave.
I'm good.
You're good.
Too cold for me to raise my arm right now.
Oh. Okay, well then, hey kids, I'm gonna end the meeting. So I'll keep you apprised on what we do in the future, and good luck, you guys. Bye-bye. Have a good.
Bye.
Mr. Shana.
Here we go. I'm
Stay
ending.
safe.